So we are building a carbon footprint reduction system, and this is using Algorand blockchain to enable this carbon reduction system.
Yeah.
And this system, go next.
So we're mainly focusing on, this is inspired by the New York City's high carbon monoxide levels. And this is like one of the infographics of some of the research that is happening. They're saying that New York City is going to become like full of carbon, pollution in the near future. So the New York City department is now like fumbling for some system to fix it all. So yeah.
Why would you need to involve public? So this system is a partnership between government and public. So government is going to build a very small carbon measuring device, and this device is mass produced, so it is very cheap, and then they will distribute it to the public. Public will pay the minimal price, $1 or $2 for it. When you own this, you come and register on our application, and then wherever you go in your car, it is a magnetic, you put it on top or side or under the trunk. It will measure and send that measurement to the government website through blockchain. So it is going to send to the blockchain, and then whenever that is done, they will earn a asset called Carbos.
Carbos.
Or what is that? Carbon coin.
Yeah.
Which is the unit name is Carbos.
Yeah. So before we actually jump onto the IoT device, currently in New York City, they have this as air monitoring. They have 25 monitoring sites throughout the entire city, and they're stable. They're not moving. They're only here. So like only in 25 areas you can find the monitoring. Except in our solution, the IoT device can be easily attached to any car or to yourself or to your home. So not only we're getting data of all the common roads, sometimes if someone leaves or goes out to the outskirts of New York City, we can get better data where there isn't enough data from these monitoring sites.
Smart use of Internet of Things. So first of all, you saw that pole which is not moving, and so this device can be very mobile, small, and also IoT device can be produced in bulk, so the cost would be very less to the government, and then this device can be directly sold to the public for future relief of cost burdens.
The more sensors there are, as I said, the higher the measurements we have for not only common roads and outside and more obscure places as well.
So in a city like New York, if you have only 5 measurement devices, how accurate that can be, so to show the state. If there are 5,000, now you can say on a graph, very granular, that where the carbon is produced more, where it is saved, and things like that.
Yeah. So for these monitoring sites that are currently in New York City, the New York City department dispatches maintenance people every month or so to like check up on whether or not the machine's running fine or not. But in our case, the user himself or herself maintains that responsibility of maintaining this IoT device, and it's fully charged and stuff like that.
One of the problem with the small and large number of IoT devices is that once the battery goes out, just to replace the battery, it costs so much to send people to all the places. People just let it go and deploy a new one. If we are giving to every individual, they will just insert new battery because they are earning coins based on that.
Yeah. So also one thing to mention is that since all this data is immediately getting published to the blockchain, it's immediately there for the public. Currently, when through those monitoring sites, New York City takes 5 to 6 months to publish that raw data that they've gotten from those monitoring sites. They have they're like data padding and stuff like that, which is largely unnecessary. So we can see the raw data immediately once it's published instead of waiting 5 or 6 months, because by then it's outdated.
And why blockchain? Why we think that blockchain is important? The blockchain can prevent tampering and inaccuracy of data metrics. So either if it is intentional or unintentional or by error, we don't know the government is publishing the right data. So that's openness and fairness and transparency. Yeah. So there is a traceability also. If the government say we measured this much, how do we measure that? How do they prove that it is right data? If it is on the blockchain, right, and the devices are owned by public, there is no ambiguity that we measured this carbon footprint on this date by this many people on this location.
And even if there's a small group of people which are malicious, their data is not going to be significant enough to affect the entire trend of the entire.
And openness is that because all this data is on blockchain, anybody can go and view that data. If there is a research institute, if there is a government, other organization, if there is a charitable organization or environmental organization, and then global reach. So not only New York can see that, whole world can see that. And if this solution is placed in other cities, in other countries, now we can consolidate the data. So these are some of the plans for the future. I will take one, you take one.
Yeah, I'll take the first one.
Okay.
So currently, there's obviously the majority of the public in New York City is probably just going to drive around the main parts of the street, main streets, main parts of the city. But those who drive around like more obscure areas where many other people are not traveling around, and if they gather data and send, we are planning to give them a higher reward in terms of carbos.
So the city government can incentivize people to go into the area where nobody is going, there is no measurement, like hills and park, some remote areas. We are also thinking of making use of Algorand smart contracts for things like lottery system. Let's say if government got some funding, they want to distribute money. So not only depend on how much you measure, but let's do the lottery, right? And then lottery itself can be done on the blockchain to show the fairness of the lottery. And getting public votes on the carbon policy decisions. If the New York has some budget of money and they want to spend on 3 programs, now they need to choose one of that. Now that itself can be done on blockchain. They can produce the options, people go and click, that click is registered in the blockchain, so nobody can mess up with that. So some of the policy decisions can be also made through this system.
Yeah, and some like additional things is that if we have a little bit more sophisticated version of the IoT device, we can measure additional pollutants, like some of the other pollutants that are affecting New York City are particulate matter and black carbon. And we can also look at temperature, humidity, etc. So now to the live demo. So this is the home page right now. So let's show you how a new user registers. So we're assuming at this point the user has already purchased the IoT device. So now they're
so he'll come in, enter his name, email, and the password.
And then they have this CO2 monitoring device ID. We just have like
that is how we are mapping who is owning this device, because device is sending us the data, not the person.
We need to connect the device to the.
So there is a pairing between this, and this happens in the blockchain.
Yeah. So now once we register, now we need to put this on the blockchain. So when we're registering,
so it is creating that account,
creating the user account,
it is setting up to receive our token asset, and then it is also XCarbon. So initially he will have zeros, everything.
0 carbos, 0 metrics, 0 miles covered, and 0 days.
So now we have already added user and some test data. So let's log into the person who has already used it for a month or so.
Yeah, so let me log out, and then now we're going to log in as a citizen. So this is an account that has already done some driving around and stuff like that. So now we're going to log in. And here we have...
So here the carbos, I query the database, right? How much carbos he has. And this is the metrics he has measured. So his device has sent so many measurements from different locations. He has covered this many miles, and then he has used it for 28 days.
How many days he's been running this?
And now he can go and say, give me Ethereum. And this is the rate I show that you will get. If you have 117, then multiply that, and then you get Ethereum, or you get Ripple, or Bitcoin, or you can get cash.
So in addition to just exchanging carbos for other Bitcoin currencies,
and here also show the carbos.
They can also just buy other things like these things.
So these are environmental friendly products that government want to promote that can be sold here. So can you buy one?
Yeah.
So let's say we have 117 carbos, and maybe you can buy whatever.
I'll just buy.
For easy calculation, we will buy one carbos.
So you can just
so
buy
117, can you buy?
And then we're buying.
Okay, so it is going on.
So now it's going to make the query.
So now I am transferring 1 carbos from him to me and
so
registering his order.
And we see it's 116.
116 carbos?
Yeah.
And now government.
Yeah, now,
Okay.
so this is all happening on the user side. Now we're going to show the dashboard for the government. So the New York City official can see the amount of pollution across the entire city. So let's log out, and then let's log in here.
This is the government login,
Yeah.
official.
So here
So
we
here-
have some sample data that we've calculated.
So because this is a time series data, you can see how it is growing over the time.
Yeah.
And also the footprint measurement,
Yeah, so
overall
this,
city.
the more red it is, the more higher concentration there is.
Yeah.
of
And how
CO2.
many monitors are currently
So
running?
the active monitors are the monitors that have been
Deployed.
employed in this city. So 500.
Total how many carbos is already given to the owners of these devices?
And this is just a similar version of this, except it's just a linear graph.
Any questions?
So, you guys are among the first developers to use the new developer portal at Algorand. Tell us about your experience.
We really loved it, and it was very helpful. Just from 3 days of going to your website, hearing it first time, we got all the examples, all the concepts was nicely laid out. There is, I think you have done a lot of good work in organizing the topics. And for those things that I didn't read, and when I came here, you just said, go there, and I was able to just look at that. Documentation is not very too verbose in the sense like I don't have to read 50, 60 pages. It's very crisp and clear.
You can find what you're looking
Yeah.
for pretty easily.
Yeah, thank you.
Congratulations.
Thank you.
Awesome job. Awesome job.
Thank you.
Awesome team.
Thank you. Thank you.